All right, now we've kind of introduced all the parts of the hypothesis testing. Let's kind of put the conclusions together. And this can be a bit of a weird spot, but before we really get into it, I want to add one thing to the previous video. So in the past, right, depending on our p-value, if the p-value is low, that's a low chance that this could have happened. So we're going to reject the null hypothesis. And a lot of times the wording that we use is there's enough evidence to suggest that the assumption isn't true. But that a lot of times has a lot of negatives in it. So what I want you to think about for this video when you're writing a conclusion is there's enough evidence to say alternative hypothesis. Okay. Let's work with that today and see how that goes. So in this first example, example A, it's the same car example that we've been working on this whole section, this whole unit. And again, it's the company's concern that they're not meeting emission standards. We found earlier, right? Earlier, we found that the null hypothesis here was that we're meeting emission standards. And then we found that the alternative hypothesis was that we are not meeting emission standards, okay? So HA was not meeting emission standards. So in the future, when we really put this whole unit together, we're going to combine everything and then, do a whole problem and find the p-value. But in this problem, just right here, the p-value is calculated for us. Here, the p-value is 0.0009. That means that if everything's working as we're assuming, so if we are working under this assumption that we are meeting emission standards, if everything's working right, there's a 0.09% chance. Convert that to a percent, you get 0.09% chance that we could have gotten this unlucky with our sample. That 0.009 means it is almost impossible for us to have sampled this poorly if we're meeting emission standards. So the natural conclusion is that we're probably not meeting emission standards. But to put that in the context of this framework, again, of p-value is low, if the p-value is small, we're going to reject the null hypothesis. And that's going to look like there's enough evidence to say alternative hypothesis. So what does that look like for this? Again, the p-value is less than our common significance level of 0.05. So again, technically what we're doing is rejecting the null. But the conclusion is a sentence. A conclusion is a sentence that anyone can understand. You tell a normal person this, they're going to look at you and say like, what the heck are you talking about? But this next sentence that we're about to write is understandable by hopefully everyone. So anyway, there is enough evidence. There is enough evidence to say alternative hypothesis. There's enough evidence to say this. There's enough evidence the company is not meeting emission standards. Okay? And that's it. All right. We're not proving anything, but we're saying there's enough evidence to make us doubt. There's enough evidence to say the company is not meeting emission standards. There's enough evidence to make us think this. We have not proven anything, but there's enough evidence to make us say, no good. To prove it, right, we couldn't use a sample. To prove it, we'd have to look at the whole population. Let's do another example. We got two more for you. Again, same example that we've been looking at before. The poverty rate was 14.8%. City official wants to find if it's different. They run the hypothesis test to determine p-value. Right, p-value here is going to be 0.273. That's 27% chance that this could have happened, which is not big, but it's not so small that we think it's impossible. It's not so small to make us suspicious. 27% chance, yeah, that's unlikely, but not so unlikely that we like raise our eyebrows up to here. You can't even see that, it's off the camera. So again, this is bigger than our significance level. We fail to reject the null. And again, this is the very formal language over here. This is the formal statistics language. But what I want for you to do is to translate that into regular English. So again, whether we're accepting the null or failing to reject the null, or rejecting the null or failing to accept the null, sorry, we have to know what the null and the alternative are, right? Remember all the way back to that first example when we were doing these hypothesis testing that we said the null hypothesis is that they have the same poverty rate as everyone else. We did that in 8b. The alternative hypothesis said that they had a different poverty rate. So again, fail to reject the null because the p-value is not sufficiently small. There is not enough evidence to, and we're going to do something very similar, there's not enough evidence to say alternative hypothesis. Again, really the conclusions are almost identical. Whether the p-value is low or whether the p-value is not low, they're almost identical. The only difference is this word right here. That's the only difference between your conclusions. Is there enough evidence for the alternative hypothesis? Is there not enough evidence for the alternative hypothesis? So here, this is not a huge p-value. It's not a huge probability, but it's big enough. It's not so small that say we should throw out the assumption. So we do not have enough evidence. This could have happened. Strong evidence is a low probability of occurring. Low probability of occurring says, whoa, that's surprising. This is good evidence. But a medium probability, this p-value being big, bigger than 5%, says we do not have enough evidence. So we don't have enough evidence to say, again, remember what it is. If the p-value is not small enough, the p-value is bigger, there is not enough evidence for alternative hypothesis. So we do not have enough evidence to say this county has a significantly different poverty rate. Or has a notably different, whatever word you want to use. This is more the statistics word. Has a significant difference in poverty rate. All right. And that's what we've got going for us. So we first identify how big the p-value is. Is this a really small p-value or not a really small p-value? We compare that to the significance level. Often 5%, but sometimes we'll specify other numbers. And that tells us whether we reject the null or fail to reject the null. That's the formal language. You don't really have to worry too much about that. Translate it into there's enough evidence for alternative hypothesis, or there is not enough evidence for alternative hypothesis. Okay? So what I want you to do is I want you to pause the video right now, and I want you to fill in this next problem. Model the last two. We've done both types. So pause the video, model the last two, and then let's see if we get the same thing, okay? So again, same example that we've done before. We had the null hypothesis. Or wait, I think we've done this before. Yeah. Maybe we haven't. I don't know. I actually don't remember now. Okay, so the null hypothesis is, right, we're looking for evidence that such side effects exist. So our alternative hypothesis is, such side effects exist. There are unwanted side effects exist. And the null hypothesis will be that no unwanted side effects exist. All right, they don't exist. We found the p-value is 0.06, which is bigger than our standard significance level. It's really close. So we're kind of on the fence around here, but we're going to be very binary about this. There is enough evidence, there's not enough evidence, when in reality, it's more of a gray area. But for this class and for a lot of basic statistics, we do set a line in the sand before running the experiment and then make our conclusions based off of that. So this is not enough evidence, it's not small enough. That's our fancy stats language. We're just going to say there's not enough evidence to say alternative hypothesis, which is that to say there's unwanted side effects. All right, and that's basically it. Let me know if you have any questions, and hopefully this helps. And in the next video, we will start putting it all together, all of these steps, and it should be a blast. Let me know if you have any questions, and have a good one. Bye-bye.